All right, now we did say before that we have Ohm's law, which is V equals IR, and we said V, it is the potential difference or the voltage in volts, and I, it's the electric current in amperes, and R is the resistance in ohms. And here I will say we wanna now learn what are the factors that affect in that resistors here. And therefore we are going to talk about resistance and resistivity. And then if I have a wire, let's say, or a conductor that is, having this shape like a tube here, it has a length L and it has a cross-sectional area, then the resistance, it equals a constant here called resistivity multiplied by L, which is the length, divided by A. And I think it's like making maybe sense that when you are really moving along that length more, like more distance, then it's gonna be having R great bigger, and then if you have A also wider, you're gonna have less R, or when you have A narrower or like smaller, it's gonna be R high. Now that resistivity, which is the constant, it is measured in ohm times meters. It has different numbers for different materials, and it's gonna tell you like how much this material is resisting current going through it. L, it's the conductor's length in meters, and A, it is the cross-sectional area in square meters. The area, it is again pi r squared. We know that resistance depending on many factors. One of them is the type of the material. The other one, which is really important, it depends on temperature. Then the resistance at any temperature equals the resistance R0 at temperature T0 multiplied by 1 plus alpha times delta T, and alpha we call it temperature coefficient of resistivity. Delta here, T, it is the difference between the two temperatures. Then you will be given the resistance at a certain temperature, and then you're gonna calculate the resistance at another temperature using alpha, which is the temperature coefficient of resistivity. Let's look at this question here. We have 4 conducting cylinders shown in the figure, are all made of the same material, though they differ in length and or diameter. They are connected to 4 different batteries, okay, and which supply the necessary voltage to give the circuits the same current. Then in all of these, we have the same current. Rank the 4 voltages, V1, V2, V3, V4, in order of increasing value. Indicate ties where appropriate. Like, is you're gonna tell what is really going in here. Now, if you look at the first circuit, we can write R1 as this is resistivity, and it has the length of 3L divided by pi, and that is really here the diameter, it is 2D. Okay, then it is we want to find what is really the radius, and then you're gonna divide 2D by 2 to get, which is 2r, and then 2r squared is going to be 4r squared. Now for number for V2 here, okay, for this one, we have R2, it is the same row because it's the same material, 2L, divided here, it's 1 diameter, then it is just R squared. R3, which is here, is gonna be rho times L divided, it's the same radius, pi r squared. R4 is going to be rho L divided by pi times 4r squared because here it's 2d. Now, in order to calculate the voltage should be I times R, and therefore, I'm gonna multiply I times rho 3L divided by pi 4r squared, which is simply this value here. And I will do this for V2, V3, V4. And then I need to compare the values. Now, when you look at this one here, you're going to find that like V4, it has just L. Okay, it said here in the order of increasing. Okay, if you compare this one and this one, you're going to find that this one here, let me write this here. I'm gonna consider V4 to be V, all right? Then here, because it is I rho L over 4 pi r squared. If we compare this one with the first one, V1 is gonna be, it has an extra 3, then it is 3 times V, because it has 4 pi r squared, the same thing. Now, if we look at V2, it is, okay, it doesn't have the 4 here, okay, but it has a 2 on top. If I will, I want to have them all of them in the same format. This is 4, then this one is 4. Then V2 is going to be 8 times V. And finally, V4 is going to, yeah, okay, then I'm done. Which one I did not do? V3. V3 is, again, if I will multiply here by 4, here by 4 to make them similar, then this is going to be 4V. Okay, then in increasing, okay, this is going to be the lowest. And then this is the second. This is the third. And finally, this is the fourth. Okay, then this is their order, all right? Now, here I have another question. A power transmission line is hung from metal towers with glass insulators having resistance of 10⁻⁹ ohms. What current flows through the insulator if the voltage is 200 kilovolts? Here I have V as kilovolts. I need to convert into volts, and then I, it is V divided by R, and then it's going to be 200 times 10⁻³ volts divided by 1/10⁹ ohms, and this is the current. A copper wire has a resistance of 0.500 at 20 degrees Celsius, and an iron wire has a resistance 0.525 at the same temperature. At what temperature are their resistances equal? Okay, here I'm gonna write two equations, one for copper and one for iron. RC, R copper here, 1 plus alpha C delta T, and Ri, 1 plus alpha times alpha I iron times delta T. Then I'm gonna distribute the RC into all the equation. Then this is RC plus RC alpha C times delta T equals Ri plus Ri alpha I times delta T. I can separate these to the left and the other terms to the right because I want to find what is delta T. And then I will plug in my numbers, and then I can find that delta T is going to be -37. The initial temperature was given to be 20, and therefore I will be able to say T is going to be 20 degrees Celsius minus 37 degrees Celsius. It is -17 degrees Celsius. One more. Um, a light has 4 times the power rating of light B when operated at the same voltage. A is the resistance of light A greater than, less than, or equal to the resistance of light B. Explain what is the ratio of the resistance of light A to the resistance of light B. Okay, we put the equation for the power, and then because they are asking about the resistance, then I should have the equation for the power, which is V squared over R. And then since the voltage is the same, it's gonna cancel. I can cross multiply, and then RB is gonna be 4RA, or RB can be written, or RA we can say it is 1/4 of RB. Now here this is about electric power and energy. Power, we have that from physics 120. It is the energy per unit time, and therefore it has units of joules per second, which is watt. Also energy, it is power times time, and here the time is gonna be in seconds. The equation, which is power equals IV, it is a general one, but also I can use, especially for resistors, another two forms derived from the original one, I squared R and V squared over R. Both are working. One more that is, okay, I think I'm gonna get this in another video.